everyone, welcome. So in this video, we'll be answering this question. We want to find the values of a and b that make f continuous everywhere. So this is our function f of x. It is defined as a piecewise function. So f of x is equal to this piece when x is less than 2. It is going to be this when x is between 2 and 3, but not including 3. And when x is greater or equal to 3, we're going to select that function. So we have three pieces of functions. Let's write down what is the definition of continuity at a point. So if you want to say f is continuous at some number a, that means the limit of the function f of x as x approaches that number a should equal to the function value at a. So that's the definition of a. Now, when we mean by the limit to exist, we mean to say that the limit of f of x as x approaches a from the left must equal to the limit of f of x as x approaches a from the right. Because once both of these limits are equal, we know the limit exists, and it's that same number, which should equal to f of a. So that's the condition we impose when we want the function to be continuous at that number a. So let's hold on to the definition. So we want to make this function f continuous everywhere. So at 2, at 3, everywhere. So first thing we're going to do is make it continuous at 2. Let's do that. So we can look at x equals 2. If I want it to be continuous at x equals 2, that means the limit of this function f of x as x approaches 2 must equal to the f evaluated at 2. And for the limit portion, we're going to break it up from left side and the right side of 2. So basically, we want the limit of f of x as x approaches 2 from the left to equal to the limit of f of x as x approaches 2 from the right. And we want both of these to equal, of course, this, which means we want that to equal f of 2. So you have equality everywhere. So let's see, what is the limit of f of x as x approaches 2 from the left? Which means we're going to look at 2 from the left, so less than 2 in this interval. That's your function to use. So we will be replacing f of x with that piece. So we have the limit as x approaches 2 from the left of x squared minus 4 over x minus 2. Okay, so now let's take this limit. Well, we need to simplify this. So I'm going to go ahead and simplify this first, because you can't do direct substitution. If you substitute 2, you'll have 0 on the denominator. That's a problem. So we have the limit as x approaches 2 from the left. We factor out x squared minus 4 as x plus 2 times x minus 2 all over x minus 2 from the bottom. And now you see that these two factors will cancel out. So we're pretty much taking the limit as x approaches 2 from the left of x plus 2. Now we can plug in the value 2. So you'll have x replaced with 2. So that will be 2 plus 2. That gives us 4. Now what do we want? We want this to equal to this limit right here, which will be same as f of 2. So let's go back. So we want the limit from x approaches 2 from the right to equal to this number 4. Now if you find the limit as x approaches 2 from the right, that means you can plug a number a little bit bigger than 2. So we're looking at this interval. So that means we need to select this function. And note that this will also be the function if f is evaluated at 2 because of that equality. So f of 2 is same as the limit of x approaches 2 from the right. So we know we're going to select that piece of the function. So let me just go back one more time. So we'll have ax squared minus bx. So the limit as x approaches 2 from the right, be using ax squared minus bx plus, go back, plus 1. So I plug in the 2 into this function. So you'll have a times 2 squared minus b times 2 plus 1 for a minus 2b plus 1. All right, so we got the limit from the left side of 2, which happens to be 4. Limit on the right side of 2 happens to be this. And we want both of these to equal because we want to make the limit to exist and that to be the function value at 2. And we said the function value at 2 is the same as this limit since we're using the same piecewise function. So therefore, we're going to create an equation. We're going to set this equal to that. So we have 4 is equal to 4a minus 2b plus 1. And then if you just move on to the other side, you have 3 is equal to 4a minus 2b. So I simply subtracted the 1 on both sides to get that. All right, so that's one equation that we need to solve. Now let's make it continuous at 3. So we'll do the same thing and create another equation since our a and b are unknown. Now we're going to use the same function to make it continuous at 3. So we'll approach the limit approaching 3 from the left. We'll be using this piece of the function. And then we'll take the limit as x approaches 3 from the right. So this is the function when x is bigger than 3. This is the interval, that's the function, which means this is the same function though you can use for f evaluated at 3 since we have the equal to. All right, so we're going to set up the following definition. So at x equals 3, we need to show that the limit as x approaches 3 from the left of this function is equal to the limit as x approaches 3 from the right. And we said that this will eventually be the same as f at 3 because when it's equal to or bigger than 3, select the same piecewise function from above. Okay, so let's find the limit as x approaches 3 from the left. So if you're approaching 3 from the left, so you can choose numbers such as 2.999, so fall into this interval, which means this is the function we're going to choose. So let's substitute that. So you'll have ax squared minus bx plus 1. I plug in 3 since it's not undefined, so direct substitution is fine. So you'll have 3 squared times a minus b times 3, and then plus 1. So this will give you 9a minus 3b plus 1. And now we take the limit from x approaches 3 from the right. So our function that we're going to choose, we're approaching 3 from the right. So we can pick number bigger than 3, a little bit bigger than 3. So that's the function. So it's 4x minus a plus b. So 4x minus a plus b. So I plug in again a value, x value into x. So you'll have 4 times, 4 times 3 minus a plus b. And this will evaluate to 12 minus a plus b. So now we set both of these equal to each other by definition. And again, f of 3 is going to be this selection as well. So we now have 9a minus 3b plus 1 is equal to 12 minus a plus b. And now let's try to manipulate this. So I'm going to go ahead and subtract 12 on both sides. So you can, well, actually, no, let me change my mind. I'm actually going to subtract 1 on both sides so I can get rid of the 1 here. So that's going to give me 11 on the right side. Then I can add a to both sides. That gives me 10a. And then I can subtract b on both sides. That's 4b. All right, so that's another set of equation I have. And now I take this equation and this equation we obtain above, create a system of equation to solve for a and b so that these conditions are satisfied. So now we have a system of equations. So we have this one, then we have 11 equals 10a minus 4b. And now we can solve for a and b. All right, so you can do it multiple ways. So I'm going to go ahead and try to get rid of b variable first. So I will take my equation 1, multiply by a negative 2. If I do that, here's what I'm going to get. So if I multiply both sides by a negative 2, I can get rid of b by adding the two equations. So you'll have negative 6 is equal to 4 times negative 2, that's negative 8a plus 4b. Second equation remain unchanged, so I just rewrite. And now I add the two equations together. So if I add the two equations together, the b cancels. So you have 5 is equal to 2a. You can divide by 2, so you have 5 over 2 is equal to the value of a. All right, wonderful. So we're able to solve for a. Now let's solve for b. Now to get b, you can plug it into either of these original equations. So I guess I'll use the very first one. So you have 3 is equal to 4a minus 2b. Plug in a in place of a. So you'll have 3 is equal to 4 times 5 over 2 minus 2b. And then you can simplify. So this is 3 is equal to, here you can reduce these by a factor of 2. That'll be 10 minus 2b. And then I subtract 10 on both sides. I have negative 7 is equal to negative 2b. You divide by negative 2. So you'll have your value for b is equal to 7 over 2. All right. So as long as a is equal to this value, b is equal to this value, our function is continuous everywhere. All right. I hope this makes sense. Take care, everyone.